Hi everyone, my name is Inventor Basic. I'm an application engineer for Micrographics. Today we're going to have a look at the basics of doing an Inventor drawing and getting a 3D representation. So the 2D sketching environment and using different functions to get it into a 3D model. We're going to have a look at step by step how I would approach this drawing and how I would create a 2D sketch of this drawing. Sometimes we are in an environment where we get a drawing from a customer and there's only view on it, only one view, no other orthographical view representations. And it would be important to remember to look at specific key factors and visualize what you're going to draw. In this instance, we only have a front view of a wheel puller. Now, the reason why I know this is circular in shape, it's because of the diameter symbols in this instance. So I can see there's a 90 diameter, and this shows me that it's circular in shape. I'll be going through step by step on the best practical way that I would approach this forward and how I would draw this. First, I'll open up a part template. Because my drawing is in millimeter, I'll be using the standard millimeter IPT and create it. I'll start my 2D sketch command and I'll choose the XY plane. The reason why I like to draw on the XY plane is that gives me a front view representation of the drawing. Because I know it's circular in shape, I know that I'll be using the revolve function. And the revolve function needs a center line or an end line or something that it can revolve around. So this is where the planing comes into play. Because I see it's circular in shape, I know I'll be revolving it around a center line. If we look at the drawing again, we can see there's an inner diameter. So I will be drawing a center line and creating this half of the drawing and revolve it around a center line. I've drawn a normal line. I'll use the coincident constraint and just place it on the center of my origin. I'll right click on the line and choose the center line option. When I look at this part over here, it almost looks like an H-shaped type drawing. Now, you need to remember and see what the best solution for you would be is how you would draw this. In this instance, I'm just going to draw an H-shaped drawing. So I'm creating a normal H-shaped drawing. You'll notice I'm tracking from that point, and you'll notice there's a dotted purple line that appears above it. That just shows I'm tracking that specific point. The same as the bottom, if I track along, you'll notice the yellow dotted line appears. That just shows I'm tracking that specific point. So I'm just creating a normal H-shaped drawing quickly. Tracking again across. And one important thing to remember, when you use the revolve function, you need to have a closed profile. You will not be able to revolve if you don't have a closed profile. Just using a line and closing the command. So that is more or less what I've drawn. When we look at the drawing itself, we can see the outside, it's 90 diameters. I'm going to choose the dimension option. I'm clicking my outside first and making that 90 diameter. I'm going to look at my inside, that it's 25 diameter. Because I'm dimensioning from this line, for instance, to the center line, you'll notice it already picks up it's the diameter, because it's from one side to the next in a circular manner. I'll notice that it's 25 millimeters high, and I'll make that 25 millimeters. When we look at the drawing again, we can see that's 9.5. I'll use the dimension again, and from there to there, just make that 9.5. I can use the dimension tool again to dimension this line over here, but in this instance, I'm going to use the equal constraint. So that line and that line would be equal. Now the reason why I tracked when I started drawing my lines, it's to make sure that they collinear, that the points are collinear. So I don't have to go use that specific constraint over there, the collinear constraint. The next dimension, it's 80 from the outside. Use the dimension again, select that line because that's the outside profile, that would be 80. Just cleaning up my drawing a bit, taking that down, and this dimension it's 40. Just to confirm, you'll notice there's a 40 diameter. Now we can notice that we still have dimensions outstanding and the drawing is not fully constrained. There's quite a lot of different ways you can do this. You can show your degrees of freedom, and it tells you your drawing can move up and down, for instance. You can hide your degrees of freedom. Now, how do you want to place this drawing? It's one of the questions that I would ask myself. I would like that center line or that origin point to be in the center of my drawing. I'm going to use the horizontal constraint, select the center of that line and make it horizontal to my origin point. And you'll notice that it's fully constrained my drawing. It still tells me one dimension is needed. That is because of my center line. Using the same constraint, I can choose that point and just make it horizontal to that. And now my drawing is fully constrained. That means my center line can't move up and down. I'm gonna select the finish sketch option and I'm going to revolve the drawing. And now we can see actually what the profile would look like. When we go to our drawing, we can notice there's a 4 radius. You can add the radius while you are busy in your 2D sketch environment. I like to use the normal 3D fillet command and choose my radius from there and create my radius. And that should be a 4mm radius. Select OK, and now I've got my 4mm radius. And there we go. That is what the profile would look like. In the next part, I will be going through on how we can add this to a drawing the sketch and look at all the different types of views and representations that we get. So please join for part 2.